Hello, welcome to another Synthium Live Hack, and happy Friday night to you. So, this week, I'm back from a couple weeks off of live hacking. Let me mute my stream, there we go. Always seem to forget about that. This week, I've been working hard for the past couple weeks, working on what you see right here. This is half of the XY gantry. It's taken me a while to get proper servo fit, figure out the potentiometer positioning, the rail system, which still isn't perfect. These rails definitely need to be smoother, but we got the proof of concept done. That's the important part. So tonight I'm gonna assemble a few more of these. We're going to try to get not only one, like the Y direction, but the X direction as well, so we can get the Rock'em Sock'em robots moving around. So that'll be exciting. I'm looking forward to making that happen. I know there's going to probably be a few bumps along the way, but we'll try to make it work as to the best of our abilities. Yeah, so a lot of these didn't print out super perfect, so I might have to do some sanding on some of these rails. They're pretty bumpy. I don't know if you can see that, but I'll try to show you. Yeah, I don't think it's going to be clear enough for you guys to see, but yeah, the prints, they sometimes come out pretty smooth, but I guess it depends what printer you're printing on, because this one that I printed on just didn't do that great of a job, so we'll have to do a bit of sanding. I'll probably leave that until last. I did want to give you a small tutorial on how to hack one of these HDD micro servos and make it into a continuous rotation servo. So I'll do a little tutorial about that. And then we'll also talk about the multi-turn clock that I purchased. So, oh yeah, and I guess I designed a bracket for it to fit in here. And then the end of here I got one of them. The end of the worm gear that goes on the servo goes into there. But how do you interface one of these guys that has that kind of Phillips end on it with one of these that doesn't have anything sticking out the end? Either you print a little piece that comes out, which is probably not strong enough, that's probably going to break off pretty quick, or you do another little hack. So I didn't know if it was going to work, but what I wanted to do is I sliced a slit down the middle, and I put a piece of metal in there, kind of like to simulate a screwdriver, and then mated that to potentiometer to move it around. So the reason why we have a potentiometer is for positional feedback for the servo. So you'll see down here, there's a wire that goes from potentiometer all the way into the servo. So servos usually have a potentiometer built in, but I wanted to be able to have multiple turns. So usually the potentiometer in the servo actually only goes 180 degrees, and it's physically limited to 180 degrees. But with one of these, if you look closely, that can turn multiple times. Actually, this one that I purchased can turn around 25 times. So the servo can move turn multiple times like that until it reaches its position. So I'll show you a quick demo. I'll flip over to Easy Builder for a second. Transition over to there. We'll connect to Wi-Fi, connect to an EZB. Listening to Spotify again tonight. Spotify, copyright-free music, NCS electronic list. Sorry guys, I almost drowned on my own water there. Yeah, I'm fairly decent at electronics, but when it comes to drinking water, still a noob. Okay, we've connected. So, one thing that I did wrong when I first hooked up this pot is that I accidentally hooked it up backward. And with a potentiometer, you think, what? That doesn't really matter. Like, if you hook up a potentiometer backwards, it's just going to read the same values. Well, when it comes to a multi-turn pot, the potentiometer spirals one way. Here, I'll show you a picture. That'll make it a little easier for you guys. Okay, here is the inside of one of those potentiometers. So here you can see there's a gear system and a worm gear. That's what you spin when you use a screwdriver on it. You spin the worm gear, and then this horizontal gear moves this way and that. It has a little wiper right here on and this is the actual resistive piece here. The wiper sits behind the gear. And anyways, so if you twist it one way, it will go up. Twist it the other way, it'll go down. And so if you have it flipped around, you can actually mess things up a little bit. So what had happened is when I hooked it up backwards, I found out that, when the servo was getting close to its intended position, it's actually it's like slowly moving away, and then it quickly moves away from it. And so that's what happens if you solder things up wrong, is that instead of getting closer to the position it wants to go to, it was trying to get away from the position. And so I had all kinds of things go wrong when I'm trying to find the positions I need, and it's like going crazy. It's going off the rails. I snapped a rail, actually snapped one of these guys right in half because of that issue that I had done. So I just desoldered these two wires, flipped it around, and it was good to go. Because the center wire is the wiper, and so didn't have to move at all. So let's get back to Easy Builder. I wrote a little script. I'll show you here. Okay, so we have a go-to, and we're on D0, so it goes to position 48, waits for 18 seconds, and then goes to position 124. Now the reason why we're waiting so long is that servo actually, it doesn't take that long to get to near the position, but it takes a while to get close to the position. So with these servos, it's an analog servo that I'm using. It has, I guess, the programming inside of the chip that it says to slow down once you get close to the intended position on the potentiometer. And so since we have it kind of moving a lot further than it actually would, you know, the servo spins multiple times, it kind of exponentially makes it slower to get to its intended position. I'll show you what I mean in a second here. So save that, and we will start. Actually, we'll transition. So how can we do this? Okay, I have another scene here. There we go. Transition to this scene so you guys can see what's happening on the gantry here. So we're going to hit start. There we go. And it starts moving. And you can see it slow down and get really slow and before it hits its intended position. And then it'll wait 18 seconds and then it'll go to the other side. And as you can see, 3D printed rails aren't always that smooth. You can see it kind of like catching a little bit and then slowly moving and then like quickly moving after it catches. So it seems to actually go really well this way, but on the way back it seems to catch. So I'm guessing it's likely that when this is 3D printed, we have kind of a barb going on where it's easy going. I don't know how to illustrate this, but you know how a barb is. Barb is kind of like a triangle, right? It's kind of facing this way. So if we're going this way, it's a little, it kind of catches, but we're going this way, it's pretty smooth. So proof of concept is done, it works. It took me a little while to figure out the values. I kind of wrote them down on here, but it's good to go. Okay, let's see if I can get you in a little closer. And as you can see, it moves fairly quickly once it's, you know, not near the intended position. And yeah, my wife Martha was looking at this worm gear section and was like, "That's pretty unique. How did you do that?" And so in Tinkercad, there's actually a way to make threads, and so you can make, you know, your standard thread size just with what's given to you with the, I think it was just called like, it was in the custom tools or the custom shapes section. I think it's called like generated shapes. And it's called an IAE metric thread. And so what I had done is actually just made, you know, a number of turns, and I elongated it by just like grabbing however many threads I had and then pulling the design up and kind of stretched it. So the reason why I stretched it out is because you want this rail system to move as fast as you can get it, because if you have it like a bunch of threads here, like say this is about 10 threads, if it was 25 threads, it would take much longer to get from this side to that side. So that's why I made that change. And I was able to fit the servo in here quite nicely. It worked a little better than I expected. This is just friction fit into here, but I didn't want it to move, so I ended up just putting some hot glue on the backside here. I could probably find a way to put a screw right through here, but there isn't much material here, so last time I put a screw through a material like this, it cracked. So I guess I could put a hole in here and then a threaded section in behind here, and that could likely lock it into place. But you know what? Hot glue is good enough and it doesn't take long. So I wanted to actually like make this thing work a whole bunch just so it could like smooth out its own rails, but it'll probably take quite a bit of time. I ended up using some 3-in-1 to try to help it along, or as DJ calls it, 4-in-1. Yeah, this stuff's awesome for all kinds of applications, including 3D printed gantry. So if you're just joining us and haven't been aware of what I've been doing, this is part 11 of our series. Here, let me switch over here to a different scene. So this is part 11 of our Rock'em Sock'em Robots hack. Yeah, it's definitely been an adventure. I put in, that means 11 Fridays of just Rock'em Sock'em Robots. And the reason why we're at this stage here, the 3D printed gantry, is that I had used recycled gantries from CD-ROMs, thinking, smart. I have these CD-ROMs and DVD-ROMs, these drives from old computers laying around. Perfect time to reuse them. So the reason why is that we wanted to move the red rocker and the blue bomber, the Rock'em Sock'em Robots. We wanted to move them all around like this, so X and Y, anywhere in between, so that they could dodge and weave and try to punch the other robot in the chin. And so the Rock'em Sock'em game came with these controls that went on the side that you shifted back and forth, left and right. And they're really ugly, and they have, here actually I can show them to you. Still have them. Right here. Yep, just super huge. You're supposed to, I think these had springs in them. Oh no, it's the springs in the robot itself, and a push down on these. And when you push these down, you activate the hands. And so the first iteration that I had done had these XY gantries that I made out of, here we go, recycled laptop drives and PC drives. The only problem was that these didn't have enough torque, and when I went to increase the current going to them, I ended up melting the motor somehow. I don't know exactly how I damaged them. I haven't really looked into it, but they are non-functional anymore. So I guess I can stop this thing. So that's why we're on this stage here. Making our own gantry out of 3D printed parts. So the reason why I went this way with a servo is that these micro servos have so much torque, and it would be no problem to move the Rock'em Sock'em robots around. The only issue is like clearance. So with the stepper motor designs, the drive designs, they're pretty thin, so there wasn't too much problems with clearance. But when you work with 3D printed parts at this smaller scale, you can't really go much smaller than a certain size, or you lose stability. You know, with these rails, you would, if they were much smaller, well, look at that. Even with them being this thick, they're still not that strong. So you lose strength if you go any smaller. Yeah, I think the 3D printer that printed these ones out just is having an issue with its Z layering. It's not very strong. But I didn't do too much of an infill in there, as you can see. I think that was only like 25 to 30%. So if I did more infill, it would also be a lot stronger. But when you're going smaller as well, you don't get all that much infill. Even you see here, there's just a line down the center pretty much, and that's about it. Where if you do more infill, you'll get more of a hatch pattern, be more solid. So tonight we're gonna have to make more of these. Like I said, I'll do a little tutorial on the servo itself, so you can make your own 360-degree moving servos out of your regular 180-degree servos. So if you're following along and you want to interact with me, definitely jump in the chat. I'll be monitoring the chat every now and again. And yeah, I'll go find a servo and I'll show you guys how to modify it. I think we'll start with that, and then we'll get into assembling the rest of these gantries. I think we'll just probably work on one full XY gantry and then test fit it with the Rock'em Sock'em robot set. Get that going. And we'll yeah, go from there. Okay, let's go find a servo. Well, I think we'll just use, oh yeah, actually no, I was going to say, use one of these servos on my desk, but I already pre-modified these ones, so that's not going to help. So I'm going to run to the back, probably take me a couple minutes, hang tight, be right back. Oh yeah, throw something in the chat, like a joke or something while I'm gone. Oh yeah, back. How's it going, man? Yeah, that plastic sure snapped pretty easy. So yeah, if I get, what am I doing? Okay, so here's the servo. Rip it out of its packaging. Okay, we have our HDD micro servo. What we're going to do is remove the 4 screws first. I'll get some of this stuff out of the way. Give myself some more room. We'll remove the 4 screws, and then I'll show you how to get these things modified. You got some pretty sweet Cylon parts there. I saw Rubber Rat. Really like the look of those things. It's gonna be awesome to see your Cylon robot come together. Okay, so pull the back off the servo first. It also always gets caught with that rubber piece there, so pop that off. You also have this little isolator. Put that aside, we'll probably keep that. If the motor pops out, just put it back in. Here. Okay, so we can get at the gear section by just pushing on the two tabs while resting our finger on there, on the output gear. Okay, so we have the gear section here. Let's remove the output gear. All I need to do is grab a flathead screwdriver and just pry that up. You don't want to bend the pin that this sits on too much, so it's on there pretty good. There we go. So there, the output gear is removed. And so you'll likely lose these gears off of here pretty easily, and let me show you the order that they go in. So it's actually fairly easy to figure out. I don't know if this thing can focus in on here. I think we're gonna have to leave it down here. So you can tell by the inner gear will have coarser teeth the further it goes up. So we'll take this gear off. This one has the largest and the most coarse teeth. This one has finer teeth. This one has finer teeth, and then the finest is the little small gear. And the small gear interfaces with the motor. So, and then these two pins, I believe, are the same size. We'll have a quick look. No, so the longer pin goes closest to the output gear. So if the gears don't fall off your servo, you're doing great. Just ignore what I've been saying for the past couple minutes here. But I'm going to put those back on. Here are the servo electronics. Oh, look at that. The gears just fell off. You know what? We'll just put them aside for now. So what we have here is two wires that go to the motor from the electronic circuit board, and then we have three wires that go to the potentiometer down there. And so what we want to do is actually remove the potentiometer because we no longer need it. We'll instead be soldering on a wire like this to go to an external potentiometer like this one, the multi-turn one. So first we'll get rid of some of that hot glue. I don't know if you can see that in there. There's some hot glue holding the potentiometer in place, as well as the screw that holds the potentiometer is underneath the hot glue. So we'll spray a little bit of rubbing alcohol in there, and I'll use my needle nose pliers to simply remove this hot glue out of here. And by simply, I mean, I'm going to do my best. It's not always simple. It takes a little bit of effort to get this stuff out of here. There we go. It's finally all out. Okay. So we'll take I think it's a number 0 Phillips screwdriver. Take that screw out of there. Keep that. Just put it aside with the gears here. And then to get the potentiometer out, we'll just push on the piece that was sticking out. So I wish we could not use the potentiometer. but it's actually what our output gear rests on. At the end here is where this plugs into. So what we'll do is we don't need to have the potentiometer for our values because we have that other one like I mentioned. So we're just going to cut the legs off the potentiometer, and then I'll desolder these wires from the electronics in a little bit here. First, let's look at this potentiometer. Now I'll use the other camera so you can see that the top end is exposed. And so if I turn this potentiometer, you can see that it runs into these little internal plastic, for lack of better terms, nubs, I guess. And so you can do one of two things. You can cut the nubs that are blocking the metal from turning, or you can just cut the metal itself. And that's what I usually do. I just take a pair of side cutters like these. I cut the tabs off the metal because the metal is actually pretty soft. It's actually much easier because when cutting off those nibs, really you could just cut off the plastic and cut it all away. It wouldn't matter. But I don't know, I find it satisfying to chop these pieces of metal off of there. And then you have the wiper down here. I'll give you guys a closer look. See a copper portion down there? It's kind of a bronze color. That's the wiper. And that will also hit those plastic nubs. So what I tend to do is take something sharp and pry it up, and then cut it off with the side cutters. So what we're doing here is essentially just making it so the potentiometer can spin. It's not going to be locked at 180 degrees like it once was. It can spin all the way around at this point. So I'm just going to cut away that wiper portion, and now you can see I can spin this 360 degrees. Okay, so let's put the potentiometer back in the servo. It has the leg portion facing towards the back of the servo. So try to fit that in. It's a little bit tricky because there's just a tiny hole that post has to fit into. So you get it in there, and then you can kind of push it down into the bottom of the servo. And then you can put your screw back in. And that will lock the potentiometer in. At this point, we can just put the gear section back together. Oh, except for the output gear. So the output gear has this pin right here. Now there's a few ways to get rid of this pin. You could use a pair of side cutters like this, but this is hardened steel and you will likely damage your side cutters. You could also try to use the side cutters to kind of pry it out, wiggle it back and forth, pull it out, but not recommended. It's pretty difficult. What I end up doing is just using a Dremel tool with a cutting wheel, and I cut the pin right off. So if you can't see the pin from there, I'll show you a close up. There's the pin on there. So that pin actually runs into this plastic plate right here on the servo. So we can't have that when it's spinning 360. So there's physical limitation. And we could cut that plate, but that pin is still going to circle around and hit the gear section. So that doesn't really work. So we're going to have to remove this pin here. So I'm going to get my safety glasses on. I'm going to grab my wire cutters, wire strippers, and just hold on to the the output gear like that, and then use the Dremel tool to cut that off. So if you have your volume turned all the way up, definitely turn it down at this time because I'm going to make a bunch of noise with the Dremel tool. So it doesn't take very long, all of 20 seconds to remove that pin. See, there it's gone. Alright, so now we can put the gear section back together. So starting with the smallest gear. You see that this is the one that has the finer gear section, more teeth. Coarser and coarser, and finally the output gear. So you might have to kind of line it up with the second stage gear, and then try to wiggle it into place. There we go. Okay, so put that shield back on, make sure it fits down perfectly. So it looks like our output gear can go a little further. You may have to press on the potentiometer and then push the output gear in to get it all the way down. There we go. Now that sits nice and flat. Okay, so before we put the back cover on, we're going to remove these wires. I'm going to desolder them, and then I'll solder on the new wires that we're going to put on there. So there's a little bit of silicone on here, so we'll just use a pick, try to remove that. That will impede our progress to try to desolder these wires off here. You can also use a pair of needle nose pliers or tweezers to get this off. Okay, good enough. So we'll make a note of the ground wire, or the brown wire here, and that'll become our brown wire for the potentiometer that we put on. Okay, there we go. Last remaining silicone. I think I'll need my trusty third hand, or fifth or sixth hand. This thing actually has quite a bit of hands. Yeah, for sure. It's yeah, thanks for the comment there, RoboRed. Yeah, it's taken me it took me a few tries to figure out what would be the best way to modify these servos, and I don't know if I'm still yet at the best way, but I've kind of refined my own process. Figured out a way. So we're going to need this third hand to hold on to these wires while we solder them. So strip these wires here. And we'll tin the tips of the wire. This makes it a lot easier when soldered onto the servo PCB. That way your solder is pre-wicked into the wire. And if you melt the insulation back a little bit too much, you can just trim off as much as you need. Alright, so let's use the third hand here. Actually, whoops, we'll use it here. And then we will solder it from this side. Try to get near the end of this. There we go. Solder it from this side and then bend it over. That's how the wires are soldered usually on these servos for a bit of strain relief. Kind of solder it this way and then bend the wires around that way. So I'll show you what I mean in a second here. Just get those 3 wires soldered on. Use some handy tweezers. There we go. Wires are soldered on. Okay. So what we'll do is we'll bend this back this way. And also make sure you don't short anything out. With these tiny servo electronics, you got to make sure you're not touching there's some capacitors that are right behind those connections. So you make sure you're not touching those. And bend that forward just like so. And then, so we have this this little strain relief rubber piece. And we can actually fit both these wires through that piece. So that's pretty handy. I'll just sneak this thing on through. It depends how soft this rubber is, I guess, but we'll see how this goes. Once you get it started, you can kind of hold the wire and push the rubber piece and then slide it on through. Okay, so slide the rubber piece down until it fits kind of like that. And then we will take our isolation piece, stick it in here so the electronics don't short out on anything. Put our electronics in, and now it's time to put the back cover on. The back cover has a slot here. See that? There we go, and that holds this the strain relief rubber. Okay, so it's all together now. Just need to screw it, finish screwing the screw it back there. There we go. One 360-degree modified servo. All we're missing now is a potentiometer. So we will solder one on. Grab one of these guys. Split the wires again. We'll do the same thing. We'll tin the wires so that they can easily be soldered to the pinchometer. And we'll also put some heat shrink on these guys. Got a piece of heat shrink here. We'll measure it to be about almost twice the size of the leg on the pinchometer. I actually trimmed down the legs because we don't really need the legs to be, where's that other one? Oh yeah, here we go. We don't need the legs to be this long, so trim them down to about maybe half that size. Sorry, probably can't see that very well. There we go. Pieces of heat shrink here. We will need to stick them on the wires first. One step that I tend to forget every now and again. It always sucks when you solder something and you're like, oh darn, I forgot to put the heat shrink on the wires. Trust me, it happens to the best of us. Okay, so I'll hold the wires with one of these guys. I'll hold the pinchometer with this guy. And we will solder them up. So I do have to pay attention to which wire goes where. Okay, so it should go like this. Otherwise we'll get some backwards, some, I guess, reverse movement that we don't want. Some solder on there. These are tweezers to get this in the right place. So that connection didn't work out that perfectly, but once I solder on a couple more of these, then it'll hold it there perfectly. We'll be able to reflow it. Okay, so move this last wire a little closer. Go. I'll reflow these other ones. There we go. So if you have any pieces of solder or stray pieces of wire that are sticking out, just trim them down with a pair of side cutters so your heat shrink can fit over top of them. The heat shrink is so none of these connections short out, so that's why I put it on there. And then use some hot air. You can use, something like a hair dryer or paint dryer, electric heat gun, but luckily for me, I have this solder rework station for soldering that's right at my bench, so it makes it easy to shrink that heat shrink. Okay, so what we'll do is we'll use our existing EZB that we have here, and we'll unplug that. We'll plug this in. I'll put this aside, and I'll stick one of these servo horns on here. So you guys can kind of see it moving. Okay. Oh yeah, I was going to show you guys something. So I designed this originally to be screwed into from the back side of the servo horn, and it was a bit annoying. And then I thought, you know what, I didn't realize this, but the screws that come with the servo actually screw right into this portion. So why not just mount it like this? And it worked out perfectly. So firstly, if you're going to be doing this permanently, you'll want to get the servo screw in there holding the servo horn on. And then you can grab 2 or 4 of these, doesn't really matter. And so they're lined up. Screw that onto there. Whoop. Try not to slip and hurt yourself. We'll just use 2 for now. Alright, so in Easy Builder, let's activate this. I'll just use the servo control. There we go. So you can see it moving one way. Depending on where this is set. Oh, interesting. It stopped for some reason. Looks like it's set around 87. Here, I'll transition to this so you can see what I'm doing in Easy Builder. So I'm just moving this value. So once it gets to 87, that's kind of the stop point. If I go above 87, looks like it's turning counterclockwise. If I go beneath 87, it turns clockwise. And you can see that the servo horn was mounted on there, not perfectly, so that's why you see that wobble. So the servo seems to be stopping after a certain time, and I'm wondering if that has to do with the protection code that's in the servo, because it should keep on continuing to move for a while. So with the new Easy Robot Micro HDD, it seems like it might stop at a certain time when it's not because it's not expecting to be in a continuous rotation servo. But with the old analog servos from Easy Robot Micro analog servo, they don't seem to be affected by that. So it looks like it moves for at least a few, well, we can time it, I guess. So put it on stopwatch mode if it stops, okay? So we'll try to do this simultaneously. Looks like 14 seconds. We'll try this again. We'll reset it. think it should be 13 seconds. Oh well, if you're going slower, it'll go for longer. I believe, yeah, it has to do with the stall protection code. So let's release that for a moment. Okay, we'll put it to its stop position, 87. And so we can actually change that stop position with the potentiometer. Let's see it moving. So now the stop position is at 79. Alright, let's try that again. I'm going to bring this up to a super high value and hit start. Should be around 13 seconds that it stops at. Oh, it's 10 seconds. Actually, maybe I'm mistaken. Maybe it is supposed to be 10 seconds. I remember at one point it was 13, but I think now it's at 10. So, well, it'll probably be in that range. So it's 11 seconds. So yeah, it's definitely the stall protection that's kicking in for some reason because it's not finding its position. So that makes sense because with a micro servo, if it's stalled against something, it can't find its position. It can't get to its position. So then it stops. And it's the same thing with this. This is not mated with this yet, so it can't find its position. So after 10 seconds of trying to get to its position, not making any headway, it'll just stop. So once it's in this configuration, it should be fine. Just in case though, I probably won't use the new digital Micro HDD. I think I'll just stick with the old analog ones. So they don't have that. They don't have that issue. And plus, I can save these digital ones for better projects and use up some of these analog ones. Okay, so I will need this this potentiometer, so I'll have to cut that off of there. I also still need this, and I'll show you how I modified this guy to interface with this. So first I made this little bracket that goes onto the gantry right there, and I made it so the potentiometer just fits its little turning piece here, the little, I don't know what you call that, the interface knob of the potentiometer, to fit just into there, and then I just push it down and just add a little bit of hot glue and it's locked into position. Actually, since this is so nicely heat shrinked and stuff, what I'll do is actually just desolder it from the board here, and then we'll do this potentiometer, this servo to be, actually I could probably solder on a couple of surface mount resistors onto here and it could be a continuous rotation servo for the rest of its life. Sounds like we're running out of battery on that drill. Okay, so I do have to modify these other servos that are over here on my bench. They're partially modified, they just have to have the potentiometer soldered on. So we'll do a bit more of this kind of soldering, get those potentiometers on there. Okay, and we'll desolder this one off of here. haven't been keeping an eye on the chat. We'll have a look in a second here. Just too busy with my hands. Okay. Well, I wasn't missing much in the chat anyway, so oh well. Alright, we have YouTube Inception going on, so let's transition to the bench here. And we will remove some of these pieces. We interface these to an analog servo. Yeah, that's pretty crazy with the stall protection. I hadn't really thought about that with these digital Micro HDDs. Makes sense when I think about it, but I wasn't expecting that. Okay, potentiometer is free. We'll put the isolation piece back in there, and we'll button this servo back up. I won't button it all the way up because I don't want to run into the servo thinking that it's good to go when it's not. So we'll pop this guy off here. But at least it kind of showed that we did a good job. Servo spins both directions. The modification was a success. Okay, so let's get these analog ones. And do the same thing. Solder on the potentiometer. Yeah, if you have any questions of what's going on here, if you're just tuning in, definitely jump in the chat, let me know. It's probably easier for you to ask your questions now rather than go through the video once again after it's all done and uploaded. These potentiometer wires on. We'll need some tweezers for this. This is super tight. Connections on the analog servo are much closer together than on the digital servos. Oh yeah, I think I shorted those together. It's just a lot of solder there, not much space. So we do have a microscope here that I might take advantage of. That's super tiny. Yeah, I think I'll resolder that center connection. Use a bit of flux, and that will help us to kind of wick away some of the excess solder. pull it away from that solder block with the tip of the soldering iron. There we go. Yeah, that's better. Okay, we're good. Oh, know what I didn't do? Darn! I didn't feed it through the rubber piece here. Okay, looks like we're gonna have to resolder this. Yeah. I'm gonna trim these right off here. It's gonna be so hard to pull through that rubber piece. You don't do that. Okay. Try to squeeze that on through. Like I said before, once you get started, you can just hold the wire in place and then push the, let's call it a grommet, this rubber piece. We'll push the grommet right over the wires. One of our wires started bending. Let's trim it a little more. Alright, there we go. Took longer than expected, but we got it. So we'll have to spread these wires out a little more again. We'll use the wire strippers, strip them, tin the ends, and then solder them to the PCB. And we'll have to do this for 3 more servos, unfortunately. I'll try to turn this a little bit. Because I only have the one proof of concept done. But actually, scratch that. We'll just do this one. Let's see if this can, there we go, get into focus. We'll just do this one, and then so we can have one X and Y gantry. Okay, so let's tin those wires. Yeah, we'll worry about the second gantry, or sorry, the third and fourth gantry some other time. I don't think we'll get it tonight. We might get to it tonight, but somehow I think we'll likely run out of time. Okay. Solder these 3 wires again, which is always tricky. Such a tight spot. Actually, these freshly cut and tinned wires actually work much better than when I was reusing the connections. All right, there we go. So same thing as last time. We'll bend the wires back around. So it's kind of look like a heart, I guess. There we go. The isolation piece for the analog servos looks a little different. Looks like a donut. There we go. Stick that in there. Put our electronics in. Slide that grommet back up. Okay. And then we'll put the back piece back on there. Go. All right, it's all together now. Now let's give it a test. That up to port D0 again. Looks like it's turning. It's a good sign. We'll transition back here to Easy Builder. And then we'll go. Are we still connected? Yes, we're still connected. Oh, so the EZB rebooted because of the inrush current from the servo. The supply that I'm using is only 1 amp, and so the inrush requirements of the servo take more than that, so it dips the voltage down and then browns out the controller. So this supply is okay for 1 servo just to be messed around, but if you move the servo quick, like I just did, it tends to reset the controller, then you have to reconnect. It's not the controller's fault, it's just the supply. So, just go up to, oh yeah, it's like, that's surprising. It's bang on 90. It's actually 91, but. So that's where the center value is. So, actually, let's leave it like that. That's actually perfect. So if we start putting the next gantry together, we'll put it into the position similar to this, where this is in the middle, and the 90 position will be around here, and then it'll go to likely a low value over this way and a higher value up here. So this one is 48. The position 48. It kind of bottoms out right at the end here, and position 124 over on this side. So we should see the same thing when we put this together. So I'm going to hot glue the potentiometer into this assembly, and then we'll start putting the other gantry together. So all these files, once I get them dialed in, I don't know if they'll be perfect this time. I mean, it looks good for one side of the gantry, but I don't know if the other side is going to fit perfectly within the body of the Rock'em Sock'em ring. So there may need to be some adjustments. Alright, first let's get this servo horn on here. That as flat as possible. Mount our worm gear onto here as well. Oh, sorry, RoboRad, I'm neglecting the chat here. Use worm gears for your tank drive on or for gear motors for your tank robots. Oh yeah, right on. Yeah, the window motors from cars are definitely pretty awesome and strong. They're kind of a worm gear system as well. Windshield wiper motors are awesome as well. They're pretty strong as well. Okay, got that all together. Here's our gantry base. Oh yeah, hot glue. Make our hot glue gun wireless by unplugging it. It stays warm for a matter of minutes after you unplug it. So. I mentioned it already in the past, but for those of you who hadn't heard of that wireless glue gun thing, it was actually a marketing gimmick at Walmart. They sold a hot glue gun of this same, I think, AdTech brand. It just, what you could do is just it had an AC cable that could unplug from the bottom, and so you would heat up your heat gun with the cable attached, and then detach it, and then work on whatever, and it would stay warm for 2 or 3 minutes. That was the wireless capabilities of the hot glue gun. It wasn't like it was battery operated or anything. It was just, let's just say it was temporarily wireless, I guess you could say. Sorry, I'll just transition here so you guys can see what's happening a little better. Okay, so we'll leave that to cool down, and we'll start mounting the rails. Unfortunately, the rails that I have here are not very smooth. These ones are super rough. I do have one that I can salvage from another previous prototype, so I'll grab the one off of here. So you might be wondering why I chose to mount the screws on the bottom side of this assembly instead of the top. So the reason was, I did have them on the top originally. The screws would go in from this side, but I thought, hey, you know what, if we have a gantry system that's going on top and has to slide around on the top of this, we don't want it to catch any of these screw heads. And plus, we already have this side where this, you can see the servo wheel or servo horn actually has a bit of clearance off of this surface here. So we have enough room to put some screw heads on this side, because this is kind of our limiting factor when it comes to clearance on this side. Okay, so yeah, pop that off, steal this rail, and we have one smooth rail. Will we need this guy? I think we do need that guy. So to pop these servos out, here, I'll bring this up a little bit so I don't have to keep on bringing stuff to that area. I'm just going to push down on the servo, it comes out the bottom. There we go. Oh, and if you can't spin it off because it hits the servo like this, all you have to do is twist the servo head. And there we go. And then you can spin this thing right off of there. Okay. And you want to put this piece, I guess I call it the gantry slide or slider. I don't know what you want to, I don't know what it's officially called when you're dealing with gantries, but spin it on like that. You'll probably want to spin it back and forth a couple times, because usually there's some little bits of plastic left over inside of there from 3D printing. If you don't print with supports, yeah, you'll have a little bit left over. If you do print with supports, you'll have a lot left over inside that assembly. So I recommend not printing with supports and just letting it do its thing. So yeah, we wanted this to be potentially in the middle, so we'll leave it around there. Okay, so we'll put it in this green assembly. I want to use this one because it's a newer prototype. This one's a revision back. Okay, so we want to put this through first. Get some of this stuff out of the way. Okay, this wire goes through here first, and the potentiometer stays on the back side. This portion goes up like this, or all of it goes up on this side, top side. And then you fit the wings into these slots. Make sure your cable doesn't get bunched up here, and simply push it into place. There we go. That's the first step of assembling the gantry portion, and then you can take, I'll use my smooth rail on this one because this is where it matters the most. And then you take the end cap of the rail, put it on like that, and then we'll screw it into place. Tools are all everywhere. Alright. Oh yes, yet again, neglecting the chat. Sorry guys. Yeah. I probably have a number of hot glue scars myself. I've definitely got a few blisters from burning myself on a hot glue gun. So yeah, be careful with that hot glue. And if it gets on your fingers, just like twist your fingers wildly like this. It'll cool the hot glue down and it'll rub right off your fingers. Okay, there we go. So one rail down. I think it's pre-oiled actually. I had some oil on this one already. And we will sand one of these guys. We'll pick the best ones, so we don't have to do much sanding. And go from there. This one's our best. Next time I'll use a different printer to print these out. So it doesn't have to be perfectly smooth because it's only just being supported by this portion here. But it does. We don't want it to catch. So. Using a bit of a lower grit sandpaper so we can get this thing done quickly. I would use some 80 grit if I had some, but I do not. Just have the 150. That's pretty decent, so already. I know the end looks like, oh yeah, I thought it was a little bit bigger, but it's actually not too bad. It fits in there already quite nicely. So I'll sand this a little more. I'll use the 220 to kind of get it nice and fine, and then we'll put some oil on it and cap it up. I recently watched a couple of YouTube videos on how to make your 3D prints look really nice. There's one guy that used, you ever seen those, he was a 3D printing gun, like a pen? Well anyways, he had kind of gone over a shape, a styrofoam ball shape with it, and it looks okay, but it's really rough, like you could really see the defined layers that he did. And so to smooth it out, he used a couple of different options. One was like a smooth on style product. Just it's kind of a chemical you put over top of it, or a lacquer. It did okay, but what really worked well is that he had a wood burning kit with this end that I'd never really seen before. It was kind of like a flat disc, and so he had just melted the plastic with a flat disc just over and over again and made it look real smooth. It was nice. Another guy who was printing with PLA. So ABS, it's known that you can just use acetone, and acetone kind of like vapor to smooth out your prints. But PLA, I think there is a chemical, but it's a little bit dangerous. I think it's potassium hydroxide that you can use with like a vapor bath to smooth it out. But what this guy had done is actually just use wood filler. So he sanded his piece, wood fillered his piece with his finger and some water, put it all over, get it in all the divots, and then sanded it again, sanded it a bunch of times, just using like a low grit to a high grit sandpaper. And then at the very end, he put some primer on it, and then there's some filler spray that he used on it, and then finally finished it off with just some classic glossy spray paint. Well, it looked amazing at the end, but man, did it look like it was a ton of work. That was pretty crazy. But yeah, it's nice to be able to make 3D prints look professional. It's very difficult because of all the layers that you can see, especially when you have a printer like this one. That did not do well with layering these rails. Okay, I think I might wash this because it has so much dust on it. I'll just wash it with a little bit of water, run to the sink, and then I'll put some oil on it. Yeah, that's pretty smooth. Smooth enough. Alright, be right back. Might as well put on some diffusing oil. Alright, I'm back. Okay, we'll put a little bit of oil on here. Make sure it's all over the place on there. Oh. I want to touch stuff with my oily fingers, so we'll clean that up a little bit. Get that rail in there. I'm actually curious to see how smooth this is going to be. Alright, so we need a few more mounting screws, and we need a mounting bracket as well. Okay, here we go. Before we put this all together, I should have modified the end of the worm gear. Forgot about that. But I guess I can do it while it's mounted. It's just going to be a little bit trickier. So in order for us to interface the worm gear to the potentiometer, we need to put like a little bit of metal there. So I was wondering what I should use today. I was kind of not really didn't really have any creative ideas on what I should use, but I knew it was going to be some thin piece of metal. And then I was working on something, and my box cutter blades were actually at the bottom, and everything was dull and ready to be replaced. And so, turns out, I looked at the blade and thought, well, you know what? That might be a perfect piece of metal to use. So, if you take off one of these sections of blade, it actually works out to be a really sturdy piece of metal that's super thin and that can interface with the potentiometer. It's thin enough. And so that's what I used, and it worked out pretty good actually. So yeah, we'll have to firstly, well, I'm going to have to keep my fingers away from here. I want to both support the worm gear and not cut off my fingers at the same time. So I'm putting my finger right here so that if I do slip, it won't slice into my hand. Alright, so it does take some time to get kind of deep into here. Yeah, we're in Canada here. We're coming up on a vote, which happens, well, some people have voted already, can do so early, but officially it's happening this Monday. So it's actually a really close election. I've never seen one so close. We'll see how it turns out. But I think, pretty sure Roborad is in Canada, so he knows what's going on. But for those of you that aren't in Canada, that's what's happening these days here in the Great White North. So on Monday night we may have a new Prime Minister, which is the President of Canada, basically. Or we might have the old one again. We'll see how it goes. Okay, so I've cut a slot into there. Could be a little bit deeper, I think. And that's where our piece of metal will fit in. And we will super glue it into place with a method that we tried last time. It seemed to work good. Oh, that's funny. Yeah, CZB hasn't seen life outside of the lab, so that's why it's so nice and white and clean. Okay, I believe we're down far enough. There we go. Press those together carefully. Okay. So now I'm going to have to go and cut a piece of utility knife blade to fit in here. Just give me a minute or so. If you have your speakers turned up, definitely turn them down again. because I will be making some noise with the Dremel tool. Okay, so I'll be over here for a little bit. Good. Okay, I don't know if this camera will pick it up, but yeah, there you go, you can kind of see the shininess. That's how small of a piece we need, and that will go right on top of here. Okay, so just give me a second, grab a clamp of some sort, so this can stay up while I'm gluing everything. Yeah, this election is pretty weird. Doesn't feel like we have a strong leader from any of the parties. So it is definitely a difficult decision. So we can test fit, make sure this fits in there without hitting the sides. It's good. So actually we're going to spray this first with accelerant. So we have the mercury adhesives accelerator, some methane hydrogen compound of some sort. Spray that on to the tip there. So we do that so that when we glue this, it'll actually take only a few moments instead of a while. Okay, there we are. It seems to be balanced pretty good. Now what we don't want to do is get this super glue near the tip, because that won't allow the metal to interface with potentiometer, so I want to keep it kind of midway to low on this thing. And we want to kind of cover it. We can cut some glue off of here later. It's always an option if we need to. So we'll glue it from every side. A decent amount on there. And then we can set it quickly by just spraying it with the accelerator once more. Okay, cast back on all this stuff, and I'll show you how that looks. Okay, there we go. So that's our metal tip for the worm gear to interface with the potentiometer. Okay, so we want to position the potentiometer probably straight up and down, and then we'll position this guy straight up and down as well. And that way they should mate up with each other very easily. It's hard to feel if it goes in perfectly or not. So we have a little bit less wire than we did with this guy here. So I'll have to hot glue it kind of along this edge like that. But yeah, for now let's put the screws into this thing. That's not a screwdriver. Whoops. Okay, there we go. Yeah, definitely the British Prime Minister does look strangely similar to Donald Trump, and I think it's just the hair that does it. I think he has maybe a toupee or something similar to Donald Trump. Okay, so we're going to have to put a little bit of pressure down here to get this screw to fit in. And I hope that doesn't mess with anything. Okay, so there we go. We're all together here. Maybe I'll put some hot glue on here as well. But before I do that, we should test it. The accelerator should have hardened up that super glue, cyanoacrylate glue, pretty decently. So let's give it a test. Okay, let's move stuff over here. Okay, so you can see what's going on. Okay, we're connected. We're at 91. Well, it helps if we're connected into the digital ports, not the analog ports. So let's move this back to 91, and we'll see if this operates the way it should. Okay, so it was slightly off 91, so it shouldn't move too much. Seems to be working. We'll find out where our end stops are. Or end stop values, I should say. Okay, so I think 21. Oh no, 122. I think is. We can go further. We'll go to 124. Wow, I think it's probably the same as this actually. Kind of funny enough. The values might be the exact same. Yeah, I don't mess around with chemicals all that much, except for these hobby chemicals, I guess you could say. So yeah, I'm mixing water to chlorine will, yeah, that probably could mess some stuff up. I mean, with enough concentration, anything with chlorine will mess stuff up. Well, let's see if we can go to 125. I'm just gonna give it a test here. Nope. Okay, 124, and our other value was 48, so let's bring this down to 50. And see how close it is. So 50 was too close. 53 seems like it's struggling with. Yeah, I think 53 is it. So this actually has less resolution than the other one. Less travel, let's say, actually. It's interesting. They're the exact same. Don't know what the difference is. It's very weird. Anyway, we have both of these completed. So the biggest challenge now is to figure out how we can put them together. Here, I think I'll just put this in the center for now. This one, see, it moves okay. Better than the other one, I think. Better than this guy. Okay, so that's pretty much where it needs to be. So this slider has some mounting holes in it, and I designed it to meet up with this guy. But in what variation, I do not know. We're gonna have to do some testing here. See, because it could go like something like that. It would have to be raised up a tiny bit with some spacers, and then this portion can fit right in, slide into here, so this can go all the way back. Here, I can kind of adjust this. So one will go in this direction, let's say the X direction, and then this one will go in the Y direction. So if we line up our holes, yeah, there's enough space for that to kind of fit in like that. So let's temporarily try that. We'll test fit that inside the ring and see how that fits. It's definitely a lot of clearance here. I mean, like a lot of height, I should say. We'll need to take care of this wire too. Kind of hot glue that down so it's not in the way of anything. And yeah, I'll use a couple of long screws to fasten this together temporarily. And we'll see how it fits. So yeah, the servos definitely supposed to move at that speed. They could be faster and they could be slower. It just depends on how you make this worm gear section. So if I elongated the threads even more, this would move a lot faster. It would get probably less resolution, but it would move quicker. And if I tighten the thread pitch, it would move a lot slower. It would have a larger value range, let's say. A lot more resolution in how it could finally move. But yeah, the trade-off is speed. I wanted these to be as fast as I could without, losing too much resolution. So this is the happy medium I arrived at. They're not too fast. I think the robot will probably move at this speed, maybe slower. Yeah, probably slower, like that. But it doesn't need to move far, so that's the only saving grace, really. The robots don't actually have that far of movement. Here, I'll switch this to the view here. So, oh, sorry guys. This thing's not tightening up. There we go. Okay, so this is the field of travel it has to go in. I measured it out. It's about 4 centimeters in the X direction, let's say, and 3 centimeters in the Y direction. So it doesn't have to go far. So it doesn't have that big of a range it can move in. Okay, what was I doing? Mounting these together. Okay. Oh yeah, and hot gluing this. Okay. We'll kind of lay that as flat as we can. Hot glue that in place. Just have to wait for a little while there. After this, we might be able to temporarily hook this up to one of the robots and see it move. We'll hook up to the power glove, one of our earlier projects on this live hack series, and we should be able to use the D-pad on the power glove to make this thing move. So I'll just put a couple more drops of hot glue here. Sorry about the weight. Just don't want this wire to get in the way. Okay, we're going to have to look in our junk drawer for some screws. Holy moly. So, I was going to mention this before, but I forgot. But I had designed all the brackets and actually everything to mount with servo screws. the screws that you get in a little baggie with your servo accessories. They're the little silver ones, and they're just under 1 centimeter, so they're about like 9 millimeters. And yeah, they're pretty decent for threading into plastic. Anyways, I had to like fish out a bunch of them out of little baggies and out of our little bin that we have. And by little I mean a pretty big bin here of servo parts. This isn't even like close to how much we actually have. We actually have like storage boxes full of these servo accessories because of how many servos we've sold in the past and collected over time. But anyway, it was just funny to me that I just pulled this little baggie out, and it turns out that we have a whole ton of these servo screws just kicking around. So to do this project, you actually won't have enough of these screws because you only get, I think, 4 in a baggie, and you use 2 here, 2 here, 2 here, 2 here, so that's 8. So you will likely have to use some from another servo, hopefully have more than that. But yeah, over time, if you are a hobbyist and have servos kicking around, you'll likely develop a bag full of these servo screws like we have. Alright, so the screws I have designed for this, I hadn't designed for this to mount like this. I think this is going to be the best way to mount it, but yeah, I hadn't accounted for that height. So we're going to have to use some random wood screws or something that we have in here. So this is the screw that I designed it for. Let's just test fit. Yeah, that's not going to make it. That should do. It's only a couple of threads in, so let's try to find something longer. That's the same length. Okay, that's a bit overkill, but that'll work. There we go. A couple of matching screws there. And they have a Robertson head. If you're not from Canada, that is a square head. Something that us Canadians developed, I don't know why. But Robertsons are super popular in Canada. But this one is actually a very annoying one. It's a number 0 Robertson. It's a very, not very common. Okay, here we go. Hopefully this screw isn't too long. Hopefully it doesn't come out the other side and bottom out. If it does, you might need some washers. Yeah, it's sticking out right here. Really, we do need some spacers to give us a little space right here so this doesn't drop down. So, what should I do? So there's 2 things I could do. I could cut the screw down. Oh man. Darn. Sorry I couldn't help you out there, old rat with screws. But yeah, if you ever need some, like a nice little baggie of a bunch of those servo screws, I might be able to hook you up. Okay, so we're gonna have to use a washer of some sort. I think I might have some 3D printed washers kicking around. from the other gantry system we used. And actually, we still have some. Here's a bunch. We still have some under here, which we don't need. Right here and here. Wait. Okay, I think that should be enough. See if the screw fits through there. I'm pretty sure it will. Yeah. Well, it doesn't fit through this one, so let's modify that washer. Get our trusty lithium drill, which is OP, overpowered. Alright, that's the size we need. Use our wire strippers to hold that in place. There we go. There. Okay. Should be good. Yep. Okay. How many will we need? That's the question. At least 3. Here, what we'll do to make this easier, we'll just stick that through there. Stick this through here. Okay. Yeah, I think that'll be fine. It's like 1/2 millimeter of clearance, but should work. Here, what we can do to raise the head of this a little higher too is use a washer on that side. Okay, hopefully this doesn't go into the mat. So it's just barely sticking out on this side. That'll work. So it looks like these two sections, because of the hot glue on the potentiometer, it actually sticks out a little when you rub against each other. So I may have to kind of shave that hot glue down a little bit. Cut away from yourself, yeah, that's probably a better idea than cutting towards yourself. There we go. Okay, hot glue shaved down on that side. Let's do it on the other side. Layers of that hot glue. There we go. There, perfect. It's not really rubbing on each other anymore. Just resting on each other. That's fine. Okay, now let's do the other side. Hopefully we have enough washers here. not, we may have to 3D print another one. I think we'll have enough. Yep, I think we do. Washer on the top like the other one. Okay, there we go. Just like the others. Okay. Alright, so let's have a look. See if we see any potential snags of what could go wrong here. Going in the Y direction, it looks unimpeded, so it looks pretty decent, like it would work. The X direction, sure. It looks like it'll be fine. So let's give it a test. Okay, plug 1 to D0. Oh, it's still sending a signal to D0. Likely for this servo. This will be D1. Alright, so let me transition here for a second. Okay. Moment of truth. Let's see if this works out. A week or 2 weeks of hard work will pay off. It seemed like every night I was doing changes to this thing and iterating. Add another servo. Horizontal is fine. Minimum. Oh yeah, let's actually set up the minimums to what they should be. So this one will be 48 and 124. Min and maximum, so we don't go above those values. Port D1, save that. So if we hit center, it should start moving. Oh, I won't for the time being. And I'll change these. Oh. That was close. Sometimes when you hit those values, that's where they want to go. So the x-axis seems to be doing pretty good. So what I'm going to do is change this to port 2 temporarily, so we can set this up without it moving. We're going to go to 53, I believe, was the value. Yeah, 53 and 124. So this gives us our bounds so we don't go outside of them. And then change this back to D0. Okay. Alright, we're going to hit center on this servo and see if the Y direction works out. So, yeah, let's mess around with it a little bit. Four. see it catches on there a little bit. I might want to smooth that rail out a little more. Okay, that's cool. Cool, it seems like both sliders aren't running into anything. Right on. Okay, we'll put them both to center. Their center values are both a little bit off of each other because the one has a different value on the lower end. Okay, and now let's see how it practically fits inside of. So let's label this for a moment D0. So I don't get them mixed up. They're not off of each other's values very much, but it doesn't hurt to be careful. Okay, so let's take this to the other camera and we'll test fit it into the ring. Okay, let me adjust this camera for a moment. Move some stuff out of the way. Transition. All right. Trusty bins help us with standing this rock'em sock'em robot ring upside down. Okay. Moment of truth. Will it fit? Will we have to do some redesigning? Okay. Okay, so I have good news and I have bad news. Good news is everything seems to line up to move the rock'em sock'em robot where it needs to go. Back and forth, perfect, forward and backward, that would work out nicely. And we're actually at a decent height. The clearance is good above the servo motors that are used to do the punching. So this can still move around underneath. Now the bad news. The bad news is this servo is running into this whole other side here. That's not good. So we could flip this 180 degrees so that this servo is on this side, and we'll see how that fits. Let's see if that's any better. See, well, the one thing that is going to be tricky is if this whole portion here is going to run into the servo here. It may not matter because our starting point for this might end up being far enough out anyway. So let's give it a test. Let's flip this around, mount it the other way, and see how it fits. I already know that I will have to increase the height of these spacers, these rubber feet here, because I tested it last week and I saw that this the servo wheel is touching the ground, or sorry, the surface that it's on. So I will have to make this a little bit higher. So I'm happy about that though. I didn't realize that clearance would be okay from these servos, so that's awesome. We will have to set up the mins and maxes of these servos so that these levers don't go too high up and run into the gantry. But for now, let's flip this over and try mounting it the other way. Okay, let's change our scene here. We also could redesign this, the portion that fits on top to be a little different than the bottom gantry portion. But we'll see. So we'd have to bring this up a little higher. Mount it like that. Here. So, you know what? Let's do some modding. Let's cut some stuff. All we have to do is like cut off like a little section right here, and this would just tuck in right there perfectly. Let's give it a shot and see how it goes. I'll just use the Dremel tool. So I'll bring this all the way back. Okay. And then see, kind of trace how much we're going to have to cut off. So it starts about at this hole and ends about there. Okay, so that's not too much. Okay, have to cut off that much, it should be fine. Okay, so, oh yeah, I guess I could hawk through this as well. Okay, I gotta use the Dremel once more. If you have your speakers turned up, watch out. Okay, I'll finish the job with box cutter. Don't cut towards yourself. There we go. Whittle these pieces down. See how that fits. Second here. Okay. Okay, so the only thing I could figure that is going to be interfering. Oh wait, no, actually it won't. I thought this wire would be interfering with the movement, but it actually ends up being like right here. It's fine. Okay, so we'll mount that there. I'll just clean this up a little bit so it looks okay. Throw that away. So if you ever actually have some permanent marker stuck on somewhere, like someone put permanent marker on your car or something, all you need to do is take a little bit of isopropyl alcohol, squirt it on the affected area, and if you have some paper towel or something, just wipe it away. So the same is true if you use a permanent marker on something, and you can actually use dry erase marker to go over top of it, and then it comes right off, because the dry erase marker has alcohol inside of it. A couple of tips and tricks I learned along the way over the years of my career. Seen some vandalism in my day. Also, if you have that marker on your face, isopropyl alcohol will take care of it as well. Okay, so let's mount that. Not sure if it's going to move smoothly or not. Maybe I should put a spacer in between. Oh yes, I should do a spacer because it looks like it's running into the heads of the screws right here. So we'll space it up a little bit. Probably one spacer will do. I'll see if that did it. Okay. Yep, it seems to be high enough now. Alright. Seems like our wire is kind of catching over here, so I think we can just move it a little bit and we'll be fine. Train it to bend in this direction. Yeah, that's good. Oh yes, we need to hot glue the servo. Okay, let's do that. Servo is hot glued. Yeah, let's hope that this fits nicely. The clearance is definitely not as, it's a much higher because now it's double stacked. So I think this is 18 millimeters plus another, well, it's going to be like 18 millimeters minus 6, so another 12 millimeters higher, so about 30 millimeters high, 3 centimeters high. joysticks out. Let this cool down a little bit more, and then we'll test fit it. Alright, let's give it a test fit. Okay, moment of truth. Okay, so that does fit better. But here's where the issue lies. We are running into this side. So we still have to have a whole another one of these on this side. So this section here is going to be in the way. Because this is like at its most bottomed out position. So if this goes any further this way, this runs into that instantly. Yeah, and the clearance here is pretty tricky. Man, I didn't think it would be it would be this big. Might have to downsize this whole thing to go even smaller. The nice thing is we have a lot of these things figured out, like the size for the servo in here, or bracket size. We can change the size of the rails and that kind of thing. This can also be chopped down for the top layer gantry. It can be a lot thinner. So these gantries, the length of this gantry is made for about 45 centimeters, or sorry, 45 millimeters, so 4.5 centimeters. So it can go in the full range side to side with this gantry here. And then this gantry was made the same, so it can do also 45. So if I made it a lot smaller to only do the 30 that we need, that would likely help. So because I made these gantries, printed them out the exact same, so if we kind of customize each one, like the top gantry and the bottom gantry, we could definitely save on some space. Not gonna lie, it's a bit disheartening that it didn't work altogether, but at least we got some of the subsystems figured out, so that's cool. But now we have to keep on scaling it down. I thought I scaled it down enough, but you know what, I would tell you the truth, I didn't really take some test measurements of this system. I just was going off of feel. And yeah, that kind of led me astray. Probably wasn't that great of an idea to do that kind of thing. Yeah, so we do have a lot of room over here too to kind of shift this gantry over. If we shifted it over enough, we could actually Yeah, I guess this gantry doesn't really matter, just thinking out loud here. It doesn't matter, like this is fine this size because it doesn't come anywhere close to this. It's really this gantry that kind of matters, how far it sticks out. So this can even be flipped over this way if it ended up fitting. Would that work? Likely not, because I can't really mount to this one because the slider goes past this bracket. I would have to make like a bracket that went over this way. So yeah, if I made a bracket that went in this area and attached it to here, that could save us some room. Just kind of thinking out loud here, because we still have some room to go back in this area. We can go all the way up to these two holes here. Could flip it, make it sit over this way. Yeah, but we would definitely need some way to attach over in this section here. So I think we could possibly make this work at this scale. Yeah, let's do some testing. Let's flip a few things around and see what we can come up with. All right, let's go back to the working table here. Oh, that's funny. Roborad is mentioning that him and his friends drew some faces on a guy that passed out, I'm guessing at a party or something, and he went on the bus with all the all the faces on him. That's pretty funny. Okay, so the idea is that we want to use up this space here and try to fit this guy. So we would have to mount it up a little higher because of that wheel to clear it. So I'm unsure about that. We could fit this over here. What if we went this way? Oh man. Can't really do that, because that fits like way too high. Would not be enough clearance. Can't go that way, would have to go this way, would have to be kind of like this. And that's not going to save us any length on this side. So it would have to be like this. It would save us a little. So we could also chop this down. We had like the mounting plate right here. So yeah, as long as we're not running into this, we'll be fine. So, and yeah, I can shorten this by chopping this off. I could design it so this rail comes this way more. Could design that. So let's hot glue this in place like this and just kind of test fit it and see how that goes. It looks like we're also going to run into this wire here along this edge, which is not so good. We'd have to put a spacer, a little bit of a spacer in there, and mount it that way. So yeah, let's hot glue that together just to test it. See if that even helps. I guess if we did pull this further this way, we could save some more room. So we can drag that in. Yeah, okay, let's do that. Get rid of this hot glue here. Shift it quite a bit over, so it'd be kind of like that. Okay, let's hot glue this there, see how it works out. Unfortunately, there's nowhere else to hot glue this thing. Nowhere else can hook onto here. Well, I guess I can just put some temporary hot glue here. I definitely spend a lot of time on these live hacks just sitting here waiting for hot glue to cool down. I mean, I could use that, you know, the cold air spray to cool it down, but you know what? I should probably use that in temporary hot glue times such as these. Okay, transition to this area over here. Okay, see how this fits. Okay, so we still have this corner hitting, and it's still going to interfere with the movement of this guy. Like I said, we could chop this back. We could like make this area much smaller in its movement, so that this kind of connects right at its edge. Because this is how far it goes on this. Ugh. Here. Let's flip it around. I'm tired of that cable is kind of getting in the way when I'm test fitting things. Okay. So let's think about this some more. It's not going to give it the full range of motion because it'll only go from here to here, which is only like 20 millimeters. I like that this servo is in this area here because that's unused space over there. None of this is needed. That's all extra stuff. So right now we're bottomed out with this guy. So this would have to mount down at its bottom. This would have to be shifted over this way, and that's where it runs into that wheel right there. And I don't think we can mount it any further down. So I feel like this axis doesn't really need to change all that much. It's kind of fine how it is. It could be shrunk down more because it is the shorter of the two axes. It doesn't have to go as far. But this axis here definitely needs to lose a lot of material. So otherwise it's going to run into this guy. So I should probably take some measurements, kind of see, okay, in relation to this gantry, where is this pin standing? That's the pin we'll be moving to make this all work. I did notice too that servo back here is running into this wheel over here, so that's not good. I know that this has to be spun a little bit, actually aimed properly. So when it's aimed, it looks like it won't run into that servo. It's good. Like I said, I really do like the idea of this servo in this area. So yeah, just kind of thinking about this and where everything needs to be. This servo can also be in this section over here. It's fine. There's a lot of space over on this side as well. So the top gantry or bottom gantry, depends how you see it, is going to definitely need lots of mods done to it. Make it much smaller, because it doesn't have to be as big as this bottom gantry is. And the bottom gantry doesn't have to be big anyway. So it's back to the drawing board. Feel like we're close, but we will definitely need to make some changes. We have our two of these servos modified, ready to go. Everything is working, functioning properly, so that's awesome. But yeah, some redesigning is needed. And since we are getting close to 10 o'clock, I think that I may have to leave the redesigning for another time. Or after this, I might do a little bit. Since I have everything here. So yeah, our clearance. Wait, can you see my mouse? If I transition to a different scene, you'll be able to see my mouse. All right, so I forgot. It'll be like Inception. Yeah, it's not gonna work that way. Frameception. So I'll just use stuff to point, but we talked about it already anyway. I'm going to be modifying this, getting this big fat piece out of the way. Get rid of that, make that whole portion smaller. So all that matters is that we get the full width, which is 4 centimeters, but it doesn't matter about kind of like the height on that. So we'll see what we can do on that one. Yeah, because like the spacing in like between here and here, that doesn't have to be large at all. That could be quite small. So we might even be able to do with a single rail. You know what? What I could do is just chop this all off here. Just cut this all right off. And just have it here and here. And then a little bit sticking out to interface with the screw here. Yeah, really, that would be fine. Of course, yeah, we need that mounting bracket on this edge as well to hook onto the slider here. But yeah, really, that's all we really need. Like I could. You know what? I don't think I can move this rail. That's fine where it is. It just matters where I can mount the pin to. So I could mount the pin on the inside of these two pieces. That could work too. Not on this side. Even save even more. And then we can also like get rid of this guy here. You guys can't even see what I'm talking about. I'm sorry. Okay. What I was just saying is that I could slice it right across here, not even needing this whole portion up here, and have this pin down here interface either right here or right here, depending on what we can get away with. Because we don't really, only this bottom layer really needs the extra slider, because we're mounting onto this piece here. on this guy, we're not really mounting anything to it. It's not like a weight lifting piece. It's just a positioning piece. So we can just chop this whole thing off. Boom! Save us all that headache, all that space, and I think it would work. Of course, we would need a bar down here, as I was saying, to mount to this. What do we call this? Like the spindle, the slider, spindle gantry slider. I don't know. I don't know what the name for that would be. It's getting late. It's 10 o'clock. I can't come up with good names right now. But yeah. Anyways, we gotta make a bar that comes down here, mounts to that, and then we can also adjust this bar here. It doesn't really need to be there. And we can get rid of a lot of this material too. Well, I guess all this material will be gone, but get rid of some material here, I should say. Just need enough to mount that servo. Cut it there, and then cut that off. Yeah, so I think that'll work. We can keep the current scale. Just do a bunch of chopping and a little adding, and I think that'll work. Right on. I think I'm happy with that. Okay, so for the time being, I'm going to put this down, and I think I'm going to sign off. Dang, I think we might be having at least I'm guessing two more videos, two more live hack sessions for Rock'em Sock'em Robots. It is slow going. This is one of the most challenging projects I've ever done, I guess, in terms of robotics. I think Voltron is a close second, but man, this one is unreal. There's a lot of mechanical engineering, I guess you could say, into this one. A lot of fitment, if you will. So yeah, I'll do some modifying, print out some more prototypes. Now that I realize that the two gantries can't be the same design, one has to be a lot different than the other. I think that's the aha moment for tonight. If you guys have any questions or anything or any comments, definitely throw it in the chat now, because we got 2 minutes until 10. So, and I think that's going to be it for tonight. Yeah, making board games and video games is a lot easier than building robots, it seems. So many variables. Form factor is definitely a huge challenge, and has been the challenge for me since day one. Like you've noticed today, I just jump into things and try stuff and see if it works or not. And there's a lot of failure with that method. I could have just thought about it more, done some more measurements, made sure that I had enough room for everything, and set out on my path that way. It definitely would save a lot of heartache, but I don't know, that's not the way my mind works sometimes, I guess. Maybe I'm more excited by the thought of just trying it and seeing if it works rather than measuring it out. Or maybe I just think that measuring is just too much work. I don't want to measure, I just want to do and see if it works out. But yeah, lesson learned. It's a lesson that I keep on learning, is that maybe you should definitely do the due diligence before, instead of having some heartache during the process. And maybe that's a lesson I can learn, I guess, through this hack series, that do some more tests before you put everything together and try to make it work. Like I could have done that. I could have done more testing, you know, with the stepper motor gantry system. See if it could actually push some stuff, and you know, could have tested it off board and have to try it all mounted together. But I think I'm more of the kind of guy that like wants to try it in application. You know, I don't want to just theorize it. I just want to get into the application and see if it'll work or not. And maybe that's to my detriment, but maybe it's a positive thing too. I don't know. I guess the positive side is that, yeah, like, I'm not wasting any time just theorizing and like, because you could always get your theories wrong on how it'll work in all their calculations when you're like, oh, why didn't I see that? Like, you know, there's just this one thing that's stuck in the way, and you're like, oh, it throws off the whole entire design. So I guess I save time that way. It's I don't know which way is best, to do all the calculations beforehand or just to get in there. Maybe it's a combination of both. But yeah, anyways, I'm just rambling. Oh yeah, one thing I did want to show you before I take off is these guys. So this was another method I was going to use if these potentiometers didn't work, these little multi-turn pots. If I wasn't able to spin that with the worm gear, I thought, hey, we can just do a linear slider potentiometer. So these are audio style, well, they're linear potentiometers, not audio potentiometers, but they're mostly used in audio. You can see like there's an LED on the end there for your soundboards and stuff. So I was going to use that to kind of like, it would probably fit here, or fit like right here or something, and then interface with the slider, and then that would pull the linear pot wiper back and forth. So that's another idea that you can do if you didn't want to use this method, is just use a linear slider pot. It definitely has enough length. I got the 45 millimeter version, so that's as much length as we have here. Well, I think I have a little bit more, but you know, the travel, because this thing is so wide, is kind of impeded, so it has about the same amount of travel as this pot. But that was an idea if these guys didn't work out, and so I had purchased these as well. Either of these is, man, this thing looks small, and it looks like it's only a potentiometer, but man, these things are like $2 a piece. They're expensive, and these ones are even more. These guys are like $3 a piece. So when deciding, don't take that decision lightly, because man, potentiometers these days, they're pricey, especially these linear or multi-turn pots. So be aware. I think that's going to be it. I've kind of rambled my way over the 10 o'clock mark. Thanks for joining me. Thanks so much. Shout out to Triple E Mister, aka Roborad from Cynthium community. He's got some awesome robots on the Cynthium community. Check him out. He's working on a Cylon and a Terminator. I don't know if it's going to be a mash of both, or if he's got two different ones. I think it's two different ones, but I haven't really looked into it that hard, to tell you the truth. He can let you guys know in the comments, but yeah, definitely check out his stuff on the Cynthium community. And yeah, just special shout out to him for all the comments he threw on tonight. He was the only one chatting me up. So next time, guys, you guys gotta throw down in the chat so I can interact with you. Anyway, have a great weekend. Thanks again for tuning in, and we'll see you next time. Good night.